Good morning, children. In today's class, we are going to learn about parabola, which is in the shape of opening up, U-curve, I can say. Where have you seen this? Whenever you go around, you could have seen cables hanging like this way. Similarly, bridges, suspension bridges, all these things are hanging like this way. Now, is that only the case? You have dish antenna on the terrace of your home. You have beautiful arches in every construction, not only your house, you can see all these beautiful arches in bungalows. And the most important idea, some of you are talking when I'm taking class and I'm disturbed, so I just want to concentrate. I'm just throwing the chalk piece on you. Can I throw straight on you? No, that is not the case. Anything that is thrown, how does it go? The chalk piece goes up and fall on you, isn't it? That is the idea of any projectile. Anything that is projected follows an upward motion and finally it falls down, and definitely it is a parabola. So the rocket that is projected from space station, or even a cracker, the rocket that we do it during Diwali season, even that follows a parabolic path. And anything that we throw, it goes up in the air like a parabola and then only it falls down. So all the falling bodies in the universe are connected with this parabolic path. The next idea, I can say anything that flows from a pipe. See, a water fountain, I can say, you could have seen in many theme parks. Or even in your home you could have had. Okay, water flows from a pipe. How does it go? This is a pipe end. Water flows like this way. And even this is following a parabolic path if I complete the other side. So remember, flowing things and then thrown things. These are the things that we see in practical life, day-to-day life situations. And so, learning parabola is quite an important thing. Now, all of us have vehicles at home, isn't it? Have you ever analyzed the headlight of the vehicle? It will be like this. And the bulb is kept somewhere here. It is not kept, it is not fixed there. It is little bit in front. That is the focus. In the focus of a parabola, the bulbs are kept so that even in distant place, the lorry or any vehicles are coming in night time, we can see the light is growing stronger and longer. Even from a distant place, I could guess some vehicle is ahead. So I can think and I can adjust my traffic according to that. Is that all? Like this, we can keep on telling. Now it's time for you to start analyzing where and how these concepts are applied. Conic sections. What are these sections actually? If you have a cone and if I slide it using a plane, intersecting a cone with a plane, it may cut this part alone, or it may cut like this, or it may cut horizontally, or it may cut little inclined. So I get various shapes, and suppose it is a double cone. And when I slide it with a slanting plane, a part will be on top and down. So such parts we call conic, because they are derived from a cone. Part of a cone when I intersect with a plane, either horizontal plane or an inclined plane, we get the various shapes, and that's the name conic. We have three different types. The very first one, earlier we learned the circles. When I cut the plane horizontally, remember when you eat cone ice cream, the heat part is gone. You have the flat surface which is like a circle. But if you keep on eating in the side, you may have a little curves like this way. C shape, I will say. Opening right or left or up or down, I call them as parabola. And if it is like an elongated circle, we call it as an ellipse. And if it is an open parabola, up and down or right and left together like this way or like this way, I call them as hyperbola. A parabola may be like this or like this or like this and like this. So there are 4 types of parabola which will be dealt in detail in this section. How to frame the equation of a conic. To derive the equation of a conic, we need a fixed point and we need a fixed line. So I am writing 2 things. We need a fixed point and we need a fixed line. A point is moving like this. How does it move? A point is moving. Say it is P. As it keeps on moving, the distance from the fixed line and the distance from the fixed point bears a constant ratio. Call the fixed point as focus. Call the fixed line, say it is L, which I can call as directrix because it directs the point. So it is called directrix. The fixed point I call focus and this distance let me call M. And now I will say SP by PM is a constant ratio and that constant we call E and E is called eccentricity. If SP and PM are equal, in that case E is 1, I get a parabola. So whenever E is equal to 1, I get a parabola. How to draw a parabola? If you are given a fixed point and a fixed line, keep the points in such a way that distance from S and distance from the fixed line are equal. So that we call as parabola. We have kept x-axis, y-axis. The fixed point we call as focus and the fixed line we call as directrix. How to draw the parabola? The distance from the directrix and the distance from the focus must be equal. See, this stick and this stick same size we have taken and they join here. So that is a point. We have taken another 2 equal sticks and one at the focus, one from the directrix. This distance and this distance are equal. Mark a point here. We have taken it another 2 equal size sticks and from here the perpendicular distance from the fixed point, the distance, both must be equal. They meet here. So join all these points to get the parabola. Just joining all the points. One point here. So the curve we have traced is a parabola. This distance and this distance are equal. Distance from a fixed point and the fixed line. Distance from a fixed point and the fixed line. The same idea here, and these points as I join, I get a parabola. What all we must know in a parabola? This point where the curve and the line of symmetry. See, this I call line of symmetry because the above and below are looking the same. The curve that is above this line and below the line are same. Something that I can divide into 2 parts is called symmetry. So this x-axis I call axis of symmetry. The fixed point we denote as S, which is called the focus with the coordinates a, 0. This distance and this distance must be equal. So we analyze an important condition from the vertex to the focus. This point we call vertex, where the axis and the curve are cutting. We call it as vertex. Vertex to focus we call the distance to be a. Vertex to directrix also the same distance. That is the equation of a parabola. Now we know what is a vertex 0, 0, what is a focus a, 0, and what is the axis x axis. I say y equal to 0 is the equation. And what is the directrix? This is 0, 0. This is to the left of it. I will say x is equal to minus a. If focus is plus a, directrix will be minus a. Focus is to the right and directrix is to the left, parallel to this axis, y axis. So this is how we draw a parabola. Remember, we say this is opening right. Exercise 3.6, question number 1. Find the equation of the parabola whose focus is the point f minus 1 minus 2 and the directrix is the line 4x minus 3y plus 2 equal to 0. Given f is equal to minus 1 comma minus 2 and directrix 4x minus 3y plus 2 equal to 0. What is the formula we learnt? Fp equal to Pm. What is P? The moving point. We can call it as xy. How to find Fp? It is the distance formula, root of x minus of minus 1. I will say x plus 1 the whole square plus y plus 2 the whole square equals to directrix. The distance of the point we will say wherever xy is coming, substitute this. That is 4x minus 3y plus 2 divided by root of square 4 square plus minus 3 the whole square. Let us remember how to write the perpendicular distance. We had the formula for perpendicular distance ax1 plus by1 plus c by root of a square plus b square. So perpendicular distance, we had a formula like this which we have used here. The point is also xy we have taken. So the same thing I will write by root of square plus square, 4 square plus minus 3 square. Whenever square root comes in the problem, we will write squaring on both the sides to get rid of the square root. So squaring on both the sides, square root and square will get cancelled. We are left with this. Expand this, x square 2x plus 1. Expand this one, y square plus 4y plus 4. This is a plus b the whole square. A square 2ab plus b square. The same idea here also. The numerator a plus b plus c the whole square. How to write it? First term square plus second term square plus third term square plus 2 into first and second 4x into minus 3y plus 2 into second and third minus 3y into 2 plus 2 into first and third. Notice how we are expanding the numerator when there are 3 terms. First term square, second term square, third term square plus twice first and second plus twice second and third plus twice first and third. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. That format we have used. Denominator square root and square will get cancelled. 4 square is 16 minus 3 square is 9. 16 plus 9 is 25. This 25 we are going to cross multiply. Before that, let us simplify the LHS. X square, y square, to write in order, 2x plus 4y, 4 plus 1, 5. The right hand side, square it, 16x square, 9y square, 4, plus into minus, minus, 2 4s are 8, 3s are 24xy, plus into minus, minus, 2 3s are 6, 2s are 12y, plus 2 4s are 8, 2s are 16x, the whole thing divided by 16 plus 9, that is 25. Cross multiply. 25 into x square plus 25 into y square plus 2x into 25 plus 4y into 25 plus 5 into 25. Bring these terms to the left. Plus 16x square will come minus 16x square. Plus 9y square will come minus 9y square. Minus 24xy plus 24xy. Minus 12y plus 12y. Plus 16x as minus 16x. 4 will come as minus 4. All I have brought to the left side, I can put equals to 0. Now see, when I bring the right hand side terms to the left, try to place them like terms together. Like terms one below the other. X square under x square, y square under y square. So like that we have placed. So what is my answer? 25x square minus 16x square. It is 9x square. Plus 25 minus 9, 16y square. 50 minus 16, it is 34x, 112y plus 121 plus 24xy equal to 0. We always write 24xy in the middle. X square term, xy term, then y square, then xy constant is the standard way of writing. So put the term before. We rewrite this as 9x square plus 24xy plus 16y square plus 34x plus 112y plus 121 equal to 0 is the equation of the parabola. So it's a simple problem highlighting the condition for a parabola FP equals to PM, where F is the focus, P is the moving point, and directrix is given. PM is the distance of the point from the directrix. We have the 4 types of parabola. The curve opening right, the curve opening left, the curve is opening up, and the curve opens down. So right, left, up and down, there are 4 types of parabola. X-axis, y-axis can be anywhere. We mark the vertex to be H, K, because every time 0, 0 cannot be the vertex. So it is good to learn the equations of parabola with H, K, any arbitrary point, that as a vertex. So we have taken A, the vertex, as H, K for all the 4 types. How to write the equation? For this curve opens right, we have y minus k the whole square equals 4a into x minus h. The same is here but negative symbol. The same is here but x and y are interchanged. X minus h goes to the left, y minus k comes to the right. So we have the third equation, and the fourth is same but negative symbol. So here only the symbol changes. Here x and y are interchanged. This x minus h goes to the left and y minus k comes to the right. Remember, all these 4 formula you must be thorough with. Now the idea is focus. Focus. What did we learn in the standard type? We learned the focus to be a comma 0. Now the vertex is h comma k. So what should I do? H, k, add with that. So what is the focus now? H plus a, k plus 0. The same idea when I come here. It is this side. So it is minus a comma 0. See, focus is to the right. It is a comma 0. Add with h comma k. When it is to the left, it is minus a comma 0. Add with h comma k because h comma k is the vertex. And when it is opening up, now the focus is here. It will be here a comma 0, here the standard model a comma 0, it will be reversed, so 0 comma a, add with h comma k. And when it is opening down, it is 0 comma minus a and add with h comma k. So these are the ideas in all the focus or vertex or wherever we write add hk. Remember, for x you add h, for y you add k. Remember that. Here a0 we add, here minus a0, here 0 a and here 0 comma minus a. How to write the directrix? What is the directrix? The fixed line. The curve goes right, directrix is left. Curve goes left, directrix is right. Curve goes up, directrix is down. Directrix will not intersect the curve, remember. Curve comes down, directrix is up. Now how to write the equation of the directrix? You have to remember these equations from which we will write the directrix. To remember, x minus h, here plus symbol means plus a equal to 0. X minus h plus a equal to 0. How to write here? The directrix is x minus h minus a equal to 0 because minus sign is there. Remember in that way. X minus h minus a equals to 0. And when you come here, y minus k only is here. So y minus k plus a equals to 0. And this part y minus k minus a equal to 0. So when you are learning, compare all the 4 types and learn together. Tabulate like this so that it will be easy for you to remember. Now lattice rectum. Lattice rectum is a card passing through the focus. So this only we call lattice rectum. Lattice rectum is perpendicular to the axis and it is a card passing through the focus. So here I can draw like this, here I can draw like this and here. Now we ought to know what is the length of the lattice rectum. In this equation or in y square equal to 4ax, the standard form, let us substitute. This is passing through the focus, means the focus coordinates you substitute and you get the length as 4a. So we get for all the 4 patterns, 4a is the length of the lattice rectum, that which comes here in the equation. So this 4a only we remember here as the length of lattice rectum. Now the next is axis of symmetry. How to write the axis of symmetry? This line we call axis of symmetry. From the equation, put the LHS equal to 0. Y minus k whole square, no need, only this bracket. So axis when I want, it is y minus k 0, it is y minus k 0, it is x minus h 0 and it is x minus h 0. So remember the technique of remembering the formula. Focus will be, in all the cases, put h comma k. Here add a0. Look at this. This is a with x. So with x you add a, the other one is 0. Here also x only is coming but minus a. So with x you put minus a. Here y is coming, so with y value you have to put plus a, and with y value you have to put minus a. For directrix, x minus h plus a equals to 0, x minus h minus a equals to 0, y minus k plus a is 0, and y minus k minus a is 0. For all the four cases, certain things are same. The vertex and the length of lattice rectum. Now, the axis of symmetry will be the LHS bracket. Put that as 0. So, these are techniques to remember and attempt your objective type or even 5-mark questions. Exercise 3.6, question number 2. The parabola y square equals to kx passes through the point 4, minus 2. Find its lattice rectum and focus. What do you mean by the word passing through the point? The point must satisfy the equation. Wherever y comes, put minus 2, and wherever x comes, put 4. We get 4 equals 4k or k equals 1. Put k equals to 1 here, so substituting k equal to 1 in the equation y square equal to kx, we get y square equal to x. So this is the equation of the parabola. Let us remember the formula. The equation y square equal to 4ax opens right. The focus is a, 0. Lattice rectum is perpendicular passing through the focus. Length of the lattice rectum, we say 4a. Comparing the given equation y square equal to x with this y square equal to 4ax, we get 4a equals 1 or a equals 1 by 4. We know the focus formula a, 0, so it is 1 by 4, 0. What is the length of lattice rectum? Length of lattice rectum, the formula is 4a and 4a is 1. That is the answer.